Welcome to the Tera scale model. Now we're dealing with 1 in a trillion. Previously we were dealing with 1 in a billion, and the solar system stretched out to 4.5 kilometers, and we couldn't really use the scale model to go much beyond that. And that was a scale model where we could show the size of the planets and the moons and the distances between them, but it just couldn't accommodate further objects. So now at 1 to a trillion, well, we can now show the orbits of the solar system in a fairly reasonable size, right? This is about the size of a basketball field. And we have the gas giants in yellow, right? From Jupiter, Saturn, Uranus, and the edge right here would be Neptune. And then we have the inner solar system, which is quite small. We have the center of the solar system with the red showing the orbits of Mercury, Venus, this is Earth, and this is Mars. So the white disk shows the orbit of Earth, and the distance, the radius of that is what we call 1 astronomical unit. The sun would be 1.4 millimeters wide, right? So I have a grain of sand, and we'll put that right in the middle as these ants walk around. So if the sun is that small, you can imagine everything else being very tiny. Beyond Neptune, we're reaching kind of the edge of the usefulness of this scale model. We're crossing the Kuiper belt, and we're approaching the point where Voyager 1 is at 160 astronomical units. It's about 1 light day away from the sun. And this is now also a point where we start feeling the darkness. So we've been used to having sunlight even within the solar system. There's still enough light to see everything. And now as we're getting to the edge here, the light is getting dimmer and dimmer. We're about 100 meters away from the sun now, 100 billion kilometers in the real scale. And out here, the sun has a brightness equivalent to a full moon as seen from the Earth. So it's getting dark and cold, and beyond here we have the realm of comets in the Oort cloud. In the previous model, the 1 to a billion, we basically started down here at this beach, and we made our way all the way 4.5 kilometers up to Neptune before we ran out of runway. And we're in a similar situation now with the 1 to a trillion. We could show the solar system just fine, but the stars are still way, way too far away. If we even thought about going 1 light year, we have to go 10 kilometers, so we have to go all the way up to those buildings in the background. And if we wanted to go to Alpha Centauri, we would have to go 40 kilometers. We'd have to go to, there's a mountain range way, way in the back on the horizon, the Olympic Mountain. So we'd have to go that far away to show stars, right? So this just goes to show there's a huge gap, a huge size difference between the solar system, the scale of the solar system, and the scale of the distance between the stars. It's one thing to colonize the solar system, to explore, and it's another thing entirely to cross over to other stars. That gap is just so much bigger. So this will play into our future, no doubt, where we'll live within the solar system for a long time before we venture out to the stars. The distance to the stars, it's so vast, it's hard for us to imagine being able to do it. Arthur C. Clarke in 1960 wrote an essay saying that, we'll never conquer space. Basically, the universe is just too big, and the speed of light is too slow. Based on our current understanding of physics, it'll just never happen. And I think to a big degree, we impose those limits onto anybody else trying to reach us, right? So if we expect somebody to create a starship that takes thousands of years to reach Earth, you would think, why would they do it, right? It would just be too big of an undertaking to cross that gap between stars. But it's only been 100 years, pretty much, since we've understood that the speed of light is a limit. And you never know what the future physics may entail. There might be other ways to get around that. You know, if we went back to the times of the Romans, they probably thought the speed limit was the fastest horse and chariot. And the idea of having breakfast in Rome, getting on a metal tube, flying to Alexandria and having lunch, that would have been like magic to them. They would not have believed that physics would allow such a thing. So we don't know. Maybe there will be ways to travel to the stars. But right now, it's certainly not something a lot of people believe is possible. We've run out of space here in the Tera model, the 1 to a trillion. And to go further, we need to go to 1 to a quadrillion, right? That would be the peta scale model. And we'll be stepping from the darkness into something even darker, right? Into the void. So the space between the stars is really a void in this journey of all the scale models. I'll see you in the next one.